Now, we've talked about naming compounds, but it's also important to understand what compounds or what can a compound look like. Now, there's three different layers or three different levels of, I guess, kind of formulas. There is the empirical formula. There is the molecular. And there is the structural formula. Now, a structural formula would be something like this. And that shows all of the atoms that are in that molecule, and it tells you kind of the organization of them. Now, a molecular formula is going to be, well, all of those atoms that are in that compound. So in this molecule, we have 1 carbon and 4 oxygens. So your molecular formula is CH4. The empirical formula is going to take the molecular formula and see if there's any sort of lowest common denominator. Can you reduce this down at all? In the case of CH4, our lowest common denominator is 1. So we really can't reduce it down. So our empirical formula in this case is the same as our molecular formula. Now that's common in some covalent compounds, but it's absolutely common in every single ionic compound. You can't really reduce those down any further. Now, another example, let's go ahead and look at the structural formula for another molecule. Let's go with this right here. Okay, now this is organized very well so that you can see all of the different atoms. And what we're going to do is we're going to locate whichever element is not hydrogen, but is farthest to the left on the periodic table. And that is carbon. That's going to be the first atom that we write. Now, what we want to do is we want to count up those carbons and then put a subscript down there. What I notice about this is that there are a total of two carbons. Next up is how many hydrogens are there? Well, there's 1, 2, 3, 4, 5, 6. So I've got 6 hydrogens. Last but not least is my oxygens. How many oxygens do I have? Well, you can count that up. There's 2 oxygens. So my molecular formula is C2H6O2. Now, with that molecular formula, I see exactly how many of each atom there are, but the molecular formula really doesn't give me an idea of which atoms are bound to one another and where they are with respect to one another. Now, molecular formula can, however, be converted into an empirical formula. And if we do that, all that we're looking for is the lowest common denominator. And what we can see in this case is that our lowest common denominator is 2. So we can have an empirical formula of C, and we're going to divide each one of these by 2. So 2 divided by 2 is 1. And you don't have to put a 1 subscript. You just move on to the next atom, because simply by writing the symbol for that atom, you show that there's 1. Hydrogen, well, H6 divided by 2, that's going to be 3. What about oxygen? Well, there's 2 oxygens. 2 divided by 2 is going to be 1. So CH3O is our empirical formula for this compound right here. So I'm going to expect you to be able to convert between structural and molecular, and empirical, but I'm not going to expect you to go from, say, a molecular formula to a structural formula. So be able to know what these different formulas are and how you can use them to learn something about a specific molecule. Well, I hope this was helpful, and I hope you have a good one.